So now, in this video, we're going to measure resistance. This is kind of a more important video than I would have thought. But in any case, set the meter to the omega symbol, and so it's out of limit. It's more resistance than what the meter can measure. So instead of like giving you random numbers, it lets you know that it's out of limit. So that's the resistance across the air over there. So to begin with, we have a 10 million ohm resistor on top there. I turned the power off the board, but none of that affects the resistors here anyways. And then we got the 1 ohm resistor on the lower part of the board, according to the Beges. Now, I'm kind of worried about the reading I'm getting because, you know, that's 11 million ohms of resistance right there. It's supposed to be 1% tolerance, so that's more than 10% off. 1% tolerance, it should be no more than 1%, either higher or lower. And this one, it's you know, a little harder to tell what the actual resistance is because there's like a little resistance where connections are and stuff. But in any case, there you can see, it's close to saying 1 right there. And that's the main thing with these low resistance measurements. It's tough to see how much resistance you actually have. So some people are worried in a video where I have connectors that don't plug into the breadboard or something, low resistance stuff, that I have to hold while I'm measuring. So you can see right now I have millions of ohms of resistance depending on how well I make this connection. And that was a pretty good connection because if I just touch like the tips right there, it's tens of millions of ohms. And the more contact I got, the lower resistance we should get for the most part. So, and it's not steady, it's going to bounce around. But in any case, then you can see I got millions of ohms of resistance. So that's going to greatly change the resistance measurement of the, I guess this is 11 million ohm resistor. It's supposed to be 10 million ohms. So if I touch the probes while I'm taking that measurement, now this resistance that you see on there is less than my body, and it's less than the 11 million ohms of resistance, of course. And so that's the way parallel resistance goes, is that you got the meter, it provides a voltage, and then you put that voltage by touching the probes across a component. It looks at how much current flows through it, and the more current that flows through it, the less resistance. So there's current flowing through the 11 million ohm resistor right there. Technically it's supposed to be 10 million ohms. And now there's also current, there's voltage across the resistor, and there's voltage across my fingers right there. So current's also flowing through my body. So it's taking that current through the resistor and the current through my body, adding them up, and then it's calculating the resistance. So the more current that you got, the less resistance the multimeter sees right there. So that's the way parallel works. So as I said before, I have videos where I measure low resistance stuff. So this plugs into the breadboard, and you know, we should have, you know, somewhat solid connections right there, holding it in place, and the probes touching it. They're not touching it perfectly, so that's going to add a little bit of resistance to it. And now, of course, my body, as we saw before, is millions of ohms of resistance, so it has, you know, a fair amount of current flowing through it. Not a ton of current, but a fair amount. So my body will definitely not add resistance. We already looked with the 11 million ohms of resistance. If anything, it's going to lower resistance. But a lot of people on my comments say, and I don't know how like serious they are or something, or if they just want to make like a comment that's hard to argue, they want to say that the resistance are adding up. But I have millions of ohms of resistance. I'm touching the probes, of course. We don't have millions of ohms of resistance on the meter right there. So if anything, me touching it is going to lower the number a little bit, unless I make a worse contact with the resistor because I start touching it right there. But I got a pretty solid contact right there, and it just dipped down, but probably just because of the way I was measuring it, it was moving or something. So yeah, usually it's like a larger thing I'm trying to measure, and so I have to like hold it and then hold the probes at the same time because I don't have a solid spot to affix it or something that you know, doesn't have a connector going. But there you can see when I'm holding it, it's not adding up the resistances right there. If anything, it's going to make it lower because I'm touching it. But because my body has so many millions of ohms of resistance, when you have a low resistance thing that you're measuring, the millions of ohms of resistance my body provides only lets a very small trickle of current flow through it, and you probably doesn't even make a change when you're measuring a very low resistance thing. Now, another thing we can do is that a lot of times, instead of holding the probe against components, I thought I was gonna do better than this. I take the alligator clips, and I have, relatively good connections with these alligator clips right there. So I just crimped with a pair of pliers these jumpers to the alligator clips, and they should not really change the 11 million ohm resistor at all compared to pressing them on there. But the 1 ohm resistor, I thought it would do better than pressing the probes against the component. But yeah, we actually have more resistance right now, so that makes sense. We got a little bit of resistance where that connection is, where I crimped them and whatever, and where I plug into the board, and so now we got to go through the board right there. So we actually have more spots where we should expect resistance to add up. But I thought it's still better than the imperfections I have when I'm pressing them on there. So if I just press the pointy spot into the hole, I don't think I will do as good. Okay, maybe that doesn't look too bad. 1.2. There's a little groove on each one of these. I don't know how well it'll show up, but yeah, I figured if I put the wire into the groove, maybe that'll make a little bit better connection. But yeah, it doesn't look like it is. Looks like it's making about the same. There we go. We went down a little bit, so maybe it is. But yeah, in any case, that was the main takeaway. If I'm measuring resistance and I touch the probes, that's not adding resistance to it. If anything, it's lowering it. And if it's a low resistance, it doesn't matter at all. You're going to get basically the same resistance there. You'll probably see no difference at all. The only time it's going to make a difference is if you're measuring something that is high resistance, like this supposed to be 10 million ohm resistor. It's like 11. Now I'm touching it, it's way off. This is not an accurate measurement of that resistor at all. I have to make sure I'm not touching them for the high resistance. Very low resistance, I can touch it. It's not changing the measurement. And so yeah, dwelling on that so much because I get the comment, I think like once a month or something. Like I was trying to measure, I believe like I crimped that right there. And so I was measuring like a connection, seeing how well it was going through there. And again, I can't plug this into the breadboard, so maybe I gotta hold it, when I measure it, and then hold the other side. Didn't realize I turned the meter off, but yeah, hold the other side, and I saw, it had, more resistance than I wanted or whatever, but still wasn't like too bad. And people are like, of course it's high, you're also touching it, but me touching it will not make it higher. So in any case, yeah, video went on a lot longer than I expected, but hopefully you still enjoyed. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.